Ever wonder how the massive tech giants push out new features, like literally all the time, without bringing their whole system crashing down? It's all about transforming software development from a tedious manual chore into a fully automated, high-speed assembly line. Today, we're demystifying CI/CD and showing you exactly how this engineering magic actually happens.
Okay, let's dive into this. Here is our roadmap for today's explainer. First, we'll talk about escaping integration hell. Then, we'll look at the CI/CD automation engine itself, break down delivery versus continuous deployment, explore GitHub Actions and Docker, and finally, wrap up as strategies for zero downtime. Section 1, Escaping Integration Hell, or the absolute chaos of manual software development. To really appreciate modern automation, we kind of have to look back at the dark ages of how software used to be built. Imagine an e-commerce app, right? You've got dozens of developers writing code simultaneously. It was a recipe for pure mayhem. Which brings us to a very real, very painful historical question. Why did developers absolutely dread Friday deployments? Well, back when everything was manual, if you deployed on a Friday evening and broke something, the entire system went down right as everyone was leaving the office. With no developers around to fix those manual errors, it led to ruined weekends and incredibly frustrated users. Here's exactly why that happened. We had a massive manual bottleneck. Multiple developers would code away on their own separate branches for weeks at a time. Then, when they finally tried to merge their work into the main branch, they would literally overwrite each other's code. After that mess, an actual human had to sit down and manually run through hundreds of tests. What takes automated systems minutes today used to take entire teams weeks of agonizing manual checks. This nightmare created what the industry calls integration hell. It was highly error-prone, a massive breeding ground for undiscovered bugs, and the reason users hardly ever got new updates. All right, Section 2, the CI/CD automation engine. Think of it as your software assembly line. Thankfully, there's a modern solution that sweeps in as the hero here, eliminating those old manual bottlenecks through the power of scripting. Let's break down the first half, the CI, or continuous integration phase. The absolute magic here is speed and instant automation. Step 1, a developer commits and pushes a code change. Step 2, a script instantly takes over to build the deployable artifacts. That just means it compiles the source code into an executable file, like a Java JR file. Step 3, it immediately blasts through hundreds of automated unit and integration tests. Instead of waiting days to find out something is broken, a developer knows within seconds. So, the crucial point here, summed up perfectly by the definition itself, continuous integration is a practice where automatic building and testing of your application happens whenever a developer pushes code. If even a single test fails during this automated check, the developer gets pinged right away, and that broken code is stopped dead in its tracks before it ever reaches a live environment. Moving to Section 3, delivery versus continuous deployment, the final step to the user. Now, what's really interesting is how often people get this next part confused, but the distinction is actually super simple when we look at that final step to the end user. In continuous delivery, your code is automatically built, tested, and deployed to a staging environment for a final look, but it stops there. It absolutely requires a manual approval from a manager before it goes to production. Continuous deployment, on the other hand, removes the human completely. If the automated tests pass, the code flows completely autonomously straight to your live production servers. Why choose one over the other? It's a fascinating architectural choice that really comes down to what you're building. Think about highly sensitive data versus agile updates. If you're developing a banking or fintech app full of sensitive financial records, you absolutely want continuous delivery. That manual managerial approval acts as a vital final safety net. But if you're building a streaming app like Netflix, you might favor continuous deployment so you can push out rapid, agile updates at lightning speed. Section 4, GitHub Actions and Docker, the tools that make it happen. Let's move from theory to the actual toolkit large engineering organizations use to build this stuff. First up is GitHub Actions. Since most source code already lives on GitHub, this automation orchestrator is natively integrated, making it incredibly intuitive. It uses YAML scripts, which are basically simple, human-readable instruction manuals, to define the workflow. You can think of GitHub Actions as the robotic arms on our assembly line, reading your exact instructions to automatically build and test your code on every single push. Working right alongside GitHub Actions is Docker. If GitHub Actions runs the assembly line, Docker is the universal shipping container. It takes your newly built application, grabs all of its dependencies, and packages the whole shebang into a standardized, executable container using a Docker file. This solves the massive, decades-old problem of developers saying, well, it works on my machine, because Docker guarantees that if the app runs perfectly on a developer's local laptop, it will run exactly the same way on the remote cloud server. Let's move on and see how this builds a complete end-to-end automated journey. First, the developer pushes code, which triggers the GitHub action. Second, the action builds the jar file and packages it into a Docker image. Third, it pushes that image up to a central repository called Docker Hub. And finally, a live AWS EC2 server automatically pulls that image and runs the container. Literally zero human intervention from a developer's laptop to a live cloud server. Final section, Section 5, Strategies for Zero Downtime, Deploying Safely to Production. So even with incredible automation, how do we update an application that thousands of people are actively using without causing a server outage or frustrating disruptions? Well, DevOps teams rely on three main deployment strategies: blue-green, canary, and rolling. And this brilliantly illustrates how they work. They handle traffic routing differently, but they all provide a critical safety net, making it super easy to roll back if a bug somehow makes it to production. Let's start with blue-green deployment. This requires maintaining two identical but totally separate environments. Blue holds your current live version, and green holds your brand new version. Once the new version is completely tested and ready on green, you instantly redirect all user traffic over to it. The massive benefit here is rollback ease. If the new version crashes, you just instantly switch the traffic back to the old blue environment, which is still sitting there completely untouched. Next is the canary deployment, named after the old coal mining practice of bringing a canary down the shaft to check for toxic gas. Instead of moving everyone over at once, you progressively test the waters. You might initially route just, say, 5 to 10% of your traffic to the new version. If those users experience no errors over a few hours, you gradually route more and more traffic until 100% of your users are safely on the new app. Finally, we have the rolling deployment. Unlike blue-green, this strategy maintains just a single environment. However, it uses a load balancer, which acts like a traffic cop, directing users to the right server, connected to multiple server instances. The new version is deployed instance by instance, gradually replacing the old one. So for a short time, you'll actually have a mix of old and new versions running simultaneously, ensuring that your application as a whole never goes offline. So as we wrap up this explainer on the incredible power of the CI/CD automation engine, I want to leave you with this question. Looking at your own work, which deployment strategy fits your current project best? By removing those ancient manual bottlenecks, we gain unprecedented speed, reliability, and honestly, a lot of peace of mind. Apply these concepts, get these tools in place, and who knows, Friday deployments might actually become a total breeze.